Right now, at the very bottom of the planet, a piece of ice the size of Florida is sliding into the ocean and it's speeding up. This is not happening in slow motion anymore. Scientists just announced that the last thing holding it back, the final slab of floating ice acting like a brake on the whole system, is about to shatter. Not in 10 years, not in 5 years, possibly this year, possibly in the coming weeks or months. This is the Thwaites Glacier. And the reason people call it the Doomsday Glacier is not because of some internet nickname gone wild. It's not because of click-hungry journalists trying to scare you. It's because of what happens if this glacier goes. If Thwaites alone melts completely, it could raise sea levels around the entire world by over 2 feet. Now, 2 feet might not sound like much when you say it out loud, but let me put it in terms that actually hit you. 2 feet of sea level rise is enough to make a normal storm surge into a catastrophic one. It's enough to permanently flood neighborhoods that have been safe for generations. It's enough to threaten entire island nations that barely sit above the waves right now. The Marshall Islands, for example, are home to 750,000 people, and most of the land there is less than 7 feet above sea level. 2 feet of rise is not a rounding error for those people. It changes whether their country survives, but here's the thing. 2 feet is just from Thwaites by itself, because Thwaites isn't just a glacier. It's a plug, a cork, a wall, holding back an even bigger body of ice behind it called the West Antarctic Ice Sheet. And if Thwaites breaks apart, then that ice sheet starts sliding into the ocean too. We are looking at over 10 feet of sea level rise. 10 feet would reshape the maps you grew up with. It would put massive sections of Miami, New York, London, Mumbai, Shanghai, and hundreds of other cities underwater. It would force hundreds of millions of people to pick up and move. That's why this glacier matters. That's why every new study, every new crack in the ice, every new measurement makes headlines. And that's why this latest warning from the scientists who study it is being taken so seriously, because they are now saying, in the clearest language they have ever used, that the last piece of floating ice holding this glacier in check is, in their exact words, poised to disintegrate. Not, might not, could if things go badly poised, as in ready as in it's happening. So today we're going to break down exactly what just happened, what the scientists found, what the evidence looks like, what's happening under the ice that most people have no idea about, and just as importantly, what this does not mean. Because the internet panic machine loves this story, and I'm not going to add to the noise. You're going to get the full, honest, no-hype version. The kind of breakdown where you walk away actually understanding the situation instead of just feeling scared. But here's the thing, this story is about to blow up. The ice shelf could break apart any day now, and when it does, every outlet on the planet is going to cover it, and most of them are going to get the details wrong. If you want to actually understand what's going on, instead of getting the exaggerated version, that's what this channel is for. Real science, real facts explained like I'm talking to a friend who deserves the truth. Hit subscribe so you have the full picture before the headlines try to scare you. It's free, it takes 1 second, and in a world where everyone is either panicking or pretending nothing is wrong, having a source that gives you the actual story is worth a lot. A like helps too, it pushes this out to more people who need the real version. Alright, now to understand why this new warning is such a massive deal, you need to understand the glacier itself first. Because if you don't know how big this thing is and how it's connected to everything around it, the warning won't land the way it should. Thwaites sits on the western edge of Antarctica. It is the widest glacier on the entire planet, stretching about 75 miles across at its front. 75 miles. To give you a sense of scale, you could line up about 3,300 football fields, end to end, across the face of this glacier, and still not cover the whole thing. It is also insanely thick. In some spots, the ice is over half a mile deep. In other spots, it's more than 3,500 feet thick. It's taller than 3 Eiffel Towers stacked on top of each other. All ice, all moving. And it is moving. Thwaites is not just sitting there like a frozen lake. It is actively flowing toward the ocean, dumping around 50 billion tons of ice into the sea every single year. That is not a typo. 50 billion tons every year? To put that in terms, you can actually feel that's the weight of about 140 billion blue whales being thrown into the ocean annually. This one single glacier is responsible for about 4% of all sea level rise happening on the planet right now. 4% from one glacier. That should tell you how monstrously large this thing is. But here's the part that elevates Thwaites from really big glacier to the most important glacier on the planet. It's not just about the ice in Thwaites itself. It's about what Thwaites is holding back. Think of it like a cork in a wine bottle. The bottle is the West Antarctic ice sheet, this enormous body of ice covering a huge portion of western Antarctica. That ice sheet holds enough frozen water to raise global sea levels by over 10 feet if it all ended up in the ocean, and Thwaites is the cork sitting at the front plugging the opening, keeping all that ice from pouring out. Scientists have also compared it to pulling a goalie out of a hockey game in the final period. If Thwaites goes, the net is wide open. Nothing is stopping the ice behind it from flowing toward the sea. That's the chain reaction everyone is worried about. Not just Thwaites melting, but Thwaites melting and taking the rest of the ice sheet with it. And if you think this is all some distant theoretical concern, here's something that might change your mind. Scientists recently discovered that Thwaites has actually been retreating since the 1940s. Not since last year, not since the 2000s, since the 1940s. For over 80 years, this glacier has been losing ground. A research team led by Julia Wellner from the University of Houston figured this out by pulling up sediment cores from the ocean floor near the glacier. These are tubes of ancient mud from the seabed, and that hold a record of what the ice was doing long before satellites existed. By studying the layers and dating them with a technique involving a radioactive form of lead, they found a clear turning point in the 1940s. Something knocked this glacier off balance. And their best theory is that it was a powerful El Niño event, one of those natural weather shifts that can temporarily warm parts of the ocean. But here's the disturbing part. That El Niño lasted maybe 2 years. The retreat it triggered has lasted over 80 years and counting. The glacier never recovered. It never restabilized. It just kept losing ground year after year, decade after decade. Wellner herself said it clearly. Once the system gets kicked out of balance, the retreat just keeps going. And another scientist on the research team, James Smith, added something that really sticks with you. Once an ice sheet retreat gets started, it can continue for decades, even if what started it gets no worse. Read that again slowly. Even if what started it gets no worse. That means even if we somehow froze the planet's temperature exactly where it is today, even if not one more degree of warming happened from this moment forward, this glacier might keep retreating anyway. The process has its own momentum now. It's like pushing a heavy shopping cart down a gentle slope. You only had to push it once. Now it's rolling on its own. And here's what makes it even more troubling. The neighboring Pine Island Glacier, one of the other biggest ice streams in all of Antarctica, started retreating at exactly the same time. Both glaciers, same region, same decade, same direction. That's not a coincidence. That tells scientists that something bigger is happening to this whole sector of Antarctica. The whole neighborhood is in trouble, not just one house. Wellner put it bluntly, if both glaciers are retreating at the same time, that's evidence they're being forced by something external, not just random changes inside the ice itself. Something is pushing both of them. And that something is the ocean getting warmer underneath them. So that's the giant we're dealing with. Massive moving, already retreating for over 80 years, dragging its neighbor along with it and showing every sign of speeding up, not slowing down. Now, let's talk about the one thing that was still holding it in check and why scientists are saying it's about to fail. Section 2, the last line of defense is failing. To understand the warning that just came out, you need to know about one very specific part of this glacier. It's called the Thwaites Eastern Ice Shelf. I know that sounds technical, but stick with me because this is the key to the entire story. Here's the simple version. Thwaites sits on land. It's a giant body of ice resting on rock, but at its front edge, where the glacier meets the ocean, a big slab of that ice extends out over the water. It floats on the surface of the sea like a giant raft still attached to the glacier behind it. That floating raft is the ice shelf. It stretches about 45 kilometers across, and it's the last major piece of floating ice still connected to the glacier's front. Now, why does this floating piece matter so much? Because it acts like a brake. Now the ice shelf pushes back against the glacier behind it. It also sits partially on top of an underwater ridge on the ocean floor, almost like an anchor point. Together, that back pressure and that anchor point physically slow down how fast the enormous body of land ice behind it can slide into the sea. Let me give you the clearest picture I can. Picture a heavy front door in your house. Now this door really wants to swing open. There's wind pushing on it from behind, and the only thing keeping it from flying open is a rubber doorstop wedged against the bottom. As long as that little wedge holds, the door barely moves. But the second that wedge breaks or slides out of the way, the door swings wide open and slams into the wall. Boom! The ice shelf is the doorstop, the glacier is the door. The wind is the warm water, and gravity pulling the ice toward the ocean. And scientists just told us that the doorstop is cracking apart and about to fail. Robert Larder is a marine geophysicist with the British Antarctic Survey. He coordinates the UK side of a massive joint research project between the United States and the United Kingdom called the International Thwaites Glacier Collaboration. This is the single biggest research effort ever aimed at understanding one glacier. Teams of scientists from both countries have been studying Thwaites up close since 2018, sending icebreaker ships drilling into the ice and deploying underwater robots. Larder is one of the people who knows this glacier best. And here's what he said. The last bit of ice shelf in front of the glacier is poised to disintegrate. He also said, and I want you to hear the certainty in this, we don't know quite how this ice shelf is going to break up, but it's definitely going to go. Definitely going to go. That's not speculation. That's not a computer model running a worst-case scenario. That's the lead coordinator of the research project telling us flatly that the last break on this glacier is coming off. He compared it to predicting an earthquake. You can see the strain building, you can measure the pressure, you know the break is coming, but you can't say exactly which day the ground is going to shift. Other scientists are backing him up with their own observations. Karen Alley at the University of Manitoba has been tracking this breakup through satellite images for years. She visited the glacier in person during the 2019 to 2020 research season. When she compared what she saw back then to what the satellites show now, she was stunned. She said there are huge gashes in the ice where there used to be none. The shelf she walked on just a few years ago is now barely recognizable from space, and Christian Wild, a geophysicist at the University of Innsbruck in Austria, put it even more vividly. He looked at the satellite images and described what he saw as looking like a windscreen that's shattering. Cracks everywhere, pieces breaking off the whole thing, losing its structural at once. The movement on the western side of the shelf, where the ice is actively breaking away from the main body, has roughly doubled in speed over just the past 8 months. 8 months. That is how fast things are changing on the ground. This is not a future warning. This is happening right now. You can see it from space if you know where to look. And the scientists who have spent their careers on this glacier are now telling the world in the clearest language they have ever used that the end of this ice shelf is not a question of if, it's a question of when, and likely soon. So what evidence convinced them? Here's where the numbers get truly staggering. Section 3, the numbers that changed everything. Scientists didn't just wake up one day and announce the ice shelf was doomed. This warning is built on over 20 years of satellite data, GPS measurements from instruments placed directly on the ice, underwater robot missions, ocean floor samples, and observations from some of the most extreme field expeditions ever, attempted on Earth. Let me walk you through the 3 biggest pieces of evidence because each one on its own is alarming. Together they tell a story that is impossible to argue with. The cracks doubled. A research team at the University of Manitoba studied satellite images of the ice shelf going all the way back to 2002. They tracked every single fracture, crack, and break in the ice over a 20-year period. What they found was that the total length of fractures in the ice shelf more than doubled. It went from around 100 miles of cracking to over 200 miles. In 2 decades, the amount of damage riddling this ice literally doubled. Think about it like a car windshield. You're driving, and a pebble hits the glass. A tiny crack appears. No big deal, you think. You keep driving. But every day, that crack gets a little longer. Then it branches. Then you notice smaller cracks spreading out from it. Eventually you look up and the whole windshield is covered in a web of fractures. At that point, one good bump and the whole thing caves in. That's what's happening to this ice shelf. Except the windshield is 45 kilometers wide and made of ice hundreds of feet thick. And the cracks aren't just getting longer, they're forming in the worst possible places. Huge fractures are opening up right around the spot where the ice shelf attaches to that underwater ridge on the ocean floor, which is the one anchor point helping hold the whole thing in place. More cracks are spreading along the grounding line, too. The exact boundary where the glacier lifts off the rock beneath it and starts to float. When those connections break, the shelf loses everything, keeping it stuck in place. The research team published their findings in the Journal of Geophysical Research, and they warned that this pattern of fracturing and collapse could serve as a warning sign for other ice shelves around Antarctica, too. This might not be a one-time event. It might be a preview of what is coming for other vulnerable shelves across the continent. The speed tripled. Scientists have been carefully measuring how fast the ice shelf is flowing toward the ocean. And the numbers have gone completely through the roof. From the start of 2020 to the start of 2026, the flow speed of the ice shelf roughly tripled. The ice is now moving at over 2,000 m per year. That's more than 1.25 miles every single year. Racing toward the ocean 3 times faster than it was moving just 6 years ago. Christian Wild, the researcher who measured this, had a reaction that says it all. He called the number frankly nuts. And Wild isn't some internet commenter trying to go viral. He's a trained geophysicist who studies ice for a living. When someone like that looks at their own data and the best word they have is nuts, that tells you the numbers are outside anything expected. But it gets worse. In an upcoming study, Wild and his team found something arguably even more concerning. They measured the speed of the glacier ice behind the shelf, not the floating ice, the land-based ice, the stuff sitting on rock. And that ice sped up by about 33% over the same period. That is a massive deal, because the ice shelf's whole job is to hold the land ice back. If the land ice is speeding up by 1/3, it means the shelf is already failing at its only purpose. The brake is still technically there, but it's barely slowing anything down anymore. It's like driving with brakes that are 33% gone. You're still pressing the pedal. You can feel some friction, but you're not stopping, and you know what happens next. And there's been further acceleration in just the last few months on top of all of that. Things are still getting faster. The retreat has been accelerating for 40 years. This isn't a sudden glitch. It's not a 1-year blip on a chart. The international team studying Thwaites reported that the glacier's overall retreat has been getting faster and faster for at least 4 decades. Every decade, It loses more ice than the decade before. The amount of ice flowing off Thwaites into the ocean doubled in 30 years. The glacier has retreated about 12 miles since 1992 alone, shedding hundreds of billions of tons in the process. And remember, this retreat started even before that. The sediment core research showed it kicked off back in the 1940s. So we're looking at a process that's been building for over 80 years and is now accelerating into what scientists fear could be a runaway phase. Put the three together. Cracks doubled, speed, tripled, retreat, accelerating for decades. That's not a trend you can wave away. That's a system telling you it's coming apart. And it's coming apart faster than even the experts predicted just a few years ago. Now, everything I just told you is what's happening on the surface, what you can see from satellites and measure with instruments on the ice. But the real engine driving all of this destruction is invisible. It's happening in total darkness, deep under the glacier in water, so cold and pressurized that no human could survive there. And to find out what was going on, scientists had to send a torpedo-shaped robot into the abyss. Section 4, the hidden attack nobody can see. Here's where the story takes a turn that most people have no idea about, because the force that's really eating Thwaites alive is not heat from the air above it. It's not sunshine. It's not anything you can see by looking at the glacier from the top. It's warm ocean water attacking it from below. Now, warm is doing a lot of work in that sentence. We're not talking about tropical water. We're talking about deep ocean water that's still pretty cold by normal standards, but warm enough and salty enough to melt ice. Scientists measured the water near the glacier's grounding line and found it was more than 3.6 degrees Fahrenheit above the freezing point. That sounds like almost nothing. But when you're talking about an unimaginable volume of water pressing against ice every second of every day, even a tiny temperature difference melts enormous amounts. And this warm water has been creeping closer to Thwaites for years. It moves through deep channels and gaps in the ocean floor, sneaking underneath the glacier like a burglar finding the unlocked back door. And once it gets under there, it goes to work on the ice's most vulnerable spots. For a long time, scientists could only guess at what was happening underneath. The area is too deep, too remote, too dangerous. No ship can get under an ice shelf. No diver could survive the conditions. So they built something that could. The robot is called IceFin. It's about 11 feet long, shaped like a torpedo, and it was specifically designed to swim in places nothing else on Earth can go. But getting IceFin to the water under the glacier was an engineering challenge that sounds almost absurd. First, scientists had to set up camp on the ice shelf itself, one of the most remote and dangerous places on the planet, where temperatures can drop well below negative 30 degrees and storms can appear with almost no warning. Then, they had to melt a hole straight down through nearly 20 feet of solid ice using a hot water drill. 20 feet. That's the 150-story skyscraper straight down through ice using heated water. Then they lowered IceFin through the hole and let it swim off into the pitch-black ocean cavity hidden beneath the glacier. A place no human has ever seen. A place no human probably ever will see. IceFin swam more than a kilometer along the underside of the ice, all the way to the grounding line, the exact boundary where the glacier lifts off the rock below and starts to float. And that grounding line is the front line of this entire battle, and IceFin got there for the first time in history. What the robot sent back changed the science. The warm water underneath the glacier isn't just sitting in a calm pool, slowly nibbling at the ice. It's being actively forced up into cracks and crevices in the bottom of the ice, pumped by pressure and ocean currents. It squeezes through gaps and openings, and when it hits the ice inside those cracks, it melts it from the inside at alarming rates. And here's the key finding. The melting is not uniform. It's wildly uneven, and the pattern matters enormously. Along the flat bottom of the ice shelf, the melting was actually slower than computer models had predicted. If that was the whole story, you might breathe a sigh of relief, but in the cracks and crevices, the staircase-shaped features in the ice base, the melting was happening at rates up to 10 times higher. The warm water finds the weak spots, the fractures, the openings, and it melts them wider and deeper. Every crack that gets wider makes the structure weaker, and a weaker structure means more cracks, which means more warm water access, which means more melting. One of the lead researchers, Brittany Schmidt from Cornell University, put it perfectly. It's not just how much melting is happening, it's how and where it's happening that matters. The where is exactly the wrong place. It's targeting the structural weak points that hold the shelf together. And it gets worse because underneath the ice there's a feedback loop going on, a vicious cycle that feeds itself. As the warm water melts ice, it creates cold, fresh meltwater. That cold melt mixes with the warm, salty ocean water and creates turbulence. Swirling currents, eddies. Scientists have observed spinning water masses miles across churning under the ice like underwater hurricanes. And these spinning currents pull even more warm water up from the deep ocean and push it against the ice. More warm water means more melting. More melting means more cold meltwater mixing in. More mixing means more turbulence. More turbulence pulls up more warm water. Round and round it goes, each cycle a little more intense than the last. One of the researchers involved warned that this positive feedback loop could gain intensity as the climate keeps warming. This is exactly the kind of self-reinforcing cycle that scientists fear most because it means the system doesn't need outside help to keep deteriorating. Once it gets going, it drives itself like a snowball rolling downhill, picking up more snow and getting bigger and faster with every rotation. But the truly frightening thing isn't the water. It's the ground. Most of its weight rests on bedrock that actually slopes downward as you move further inland away from the coast. Picture a bowl. The rim of the bowl is the coastline. The bottom of the bowl is deep under the ice miles inland. The deeper the ice sits, the more of it is below sea level and exposed to the ocean. This creates a nightmare scenario that scientists call marine ice sheet instability. And in plain language, it works like this. As the glacier retreats the grounding line, the point where ice lifts off the rock and starts to float moves back into deeper water. Deeper water means a taller face of ice is exposed to the ocean. A taller ice face is heavier and more likely to crack and break off under its own weight. When it breaks, the grounding line retreats even further into even deeper water where the ice face is even taller and even more unstable. And the whole process repeats. It's like a ball rolling down a slope that gets steeper the further down it goes. Every inch it rolls, it picks up speed, and at some point there's nothing that can stop it. Computer simulations have made scientists, as one researcher put it, almost certain that this is how the glacier will eventually collapse if the grounding line retreats too far. A few years ago, researchers were saying, yeah, this could happen, but we really don't know. Now they're saying it's nearly a certainty that it will happen someday. The shift in confidence is significant. They've gone from uncertainty to near certainty. The only thing they still can't predict is when that tipping point arrives. Whether it's in our lifetimes or our grandchildren's lifetimes. And here's the terrifying part. You can't test it. You can't run an experiment on a glacier the size of Florida. You can't press pause and try again. Once the grounding line crosses that invisible threshold and the runaway retreat begins, there's no rewind button. There is no engineering fix that can put ice back on a mountain at this scale. It's a one-way door. And every measurement, every new crack, every degree of ocean warming nudges Thwaites closer to that door. One of the reasons scientists are so worried right now is that all of these warning signs are happening at the same time. The cracks are spreading, the ice is speeding up. The warm water is attacking from below. The feedback loops are getting stronger. The grounding line is retreating. And the ground underneath is shaped in exactly the way that makes runaway collapse possible. It's not one thing going wrong, it's everything going wrong at once, all pointing in the same direction. That's what makes this moment different from previous warnings. And the human effort to understand all of this is genuinely remarkable. It's worth pausing on because I think most people have no idea what it takes to study this glacier. Since 2018, the International Thwaites Glacier Collaboration, this joint project between the United States and the United Kingdom, has been sending teams to study Thwaites up close. These are not quick day trips. These are months-long expeditions to one of the most remote and dangerous places on the face of the planet. In early 2026, a team of nearly 40 researchers from around the world boarded a Korean icebreaker called the Arion and sailed through some of the most treacherous waters on Earth to reach Thwaites. The sea ice they had to push through was so thick and so dense that for a while they genuinely weren't sure they were going to make it. The ship's science reporter, who was broadcasting from on board, described the ice as being like molasses. The ship crawled forward, crunching through pack ice for days, burning fuel and time. But they made it. And once they reached the glacier, the real work began. They flew 2 helicopters onto the ice surface in conditions that would make most pilots refuse to take off. Temperatures plunged well below zero. Winds kicked up with almost no warning. Visibility could drop to near zero in the space of minutes. On the ice, the teams drilled boreholes straight down through hundreds of feet of solid ice using hot water. They lowered instruments and sensors into those holes to measure the temperature, the salinity, and the movement of the water underneath. They gathered data that no satellite can capture. Data that can only come from being physically present in this hostile, freezing, wind-blown place at the end of the world. Previous expeditions had done similar work, and each one brought back information that changed the science. It was earlier field teams who deployed ice fin, who first saw the warm water eating at the grounding line, who first measured the uneven melting in the crevices. All of that knowledge came from people willing to spend months in brutal conditions to answer one urgent question. How soon and how fast will this giant give way? Every one of these expeditions is an act of genuine courage. These are scientists who leave their families for months to work in sub-zero temperatures in a place where a storm can make it impossible to see your hand in front of your face, all to get data that the rest of the world needs. And every time they come back, the data tells the same story. Thwaites is losing its grip, and the process is speeding up. Section 5. So what does this actually mean for us? All right, we've gone through a lot. The glacier itself, the ice shelf, The cracks, the speed, the warm water underneath the torpedo robot swimming through places humans have never been, the feedback loops making things worse, the shape of the ground, setting the stage for a runaway collapse, and the courageous scientists risking everything to measure it all. It's a lot to take in, and right now your brain is probably doing one of two things. Either you're thinking, this is the end of the world, and coastal cities are going to be underwater next Tuesday, that the oceans are about to surge and we need to head for the hills, or you're thinking, come on, scientists always predict the worst case and nothing ever happens. It'll be fine. It always is. Both of those reactions are wrong, and I mean that. They're both wrong for different reasons, and landing on either one means you've missed the actual story. This is the part where I have to be fully honest with you, because this is exactly the point where most coverage of this story goes off the rails. The panic version exaggerates the speed. The dismissive version ignores the science, and I refuse to do either. Let me be very clear about what this warning does not mean. It does not mean the ocean rises 10 feet this year. It does not mean Thwaites collapses into the sea tomorrow. It does not mean Miami or London or Mumbai goes underwater in 2026. If someone tells you that, they're either confused about the science or deliberately trying to scare you. Here is what it does mean. The floating ice shelf at the front of Thwaites, the thing that has been acting as a break on the glacier, is about to break apart. When that happens, it will not by itself cause a sudden jump in sea levels. And the reason is actually simple. That shelf is already floating. It's already in the water. And floating ice that melts doesn't add to sea level, the same way an ice cube melting in a glass of water doesn't make the glass overflow. The water level stays the same because the ice was already displacing its weight in water. But here's the critical part that most people miss. Once that floating shelf breaks away, the land-based ice behind it, the massive body of ice that is sitting on rock that is not floating, starts sliding into the ocean faster than before because the break is gone. Nothing is pushing back against it anymore. When land ice slides into the ocean and melts, that raises sea levels. That's the ice that matters. So the ice shelf breaking is not the flood. The ice shelf breaking is what removes the last thing, slowing the flood down. Here's an analogy that might help. You're in a car rolling down a hill and your brakes are wearing thin. You can feel them fading. The car is getting faster. Then one day the brakes give out completely. That exact moment is not when you crash. It's not the end, but it's the moment the car starts accelerating with nothing to slow it down. How soon you reach the bottom depends on how steep the hill is, how fast you pick up speed, and what's in your path. The brake failure is the turning point, not the end point. That's exactly what the ice shelf breakup is, a turning point. So, what happens after the brake comes off? Scientists say Thwaites will retreat further and faster. Models suggest that by around 2067, the glacier could be losing between 180 and 200 billion tons of ice per year. That's almost 4 times the roughly 50 billion tons it sheds now. Over decades and centuries, that ice loss adds up to enormous sea level rise. If just Thwaites fully collapses over time, sea levels rise about 2 feet globally. 2 feet might sound manageable until you realize what 2 feet actually does. It doesn't just mean the water line moves up a bit. It means every storm surge, every hurricane, every king tide reaches further than it ever has before. It means neighborhoods that flood once a decade start flooding every year. It means underground pipes and tunnels in coastal cities start filling with salt water from below. It means the fresh water supply in places that get their drinking water from underground wells near the coast starts getting contaminated with salt. 2 feet is a number that quietly wrecks infrastructure, property values, and lives for millions of people. And remember, that's just from one glacier. If the collapse of Thwaites destabilizes the rest of the West Antarctic ice sheet, which many scientists think it could, the total sea level rise could reach over 10 feet. 10 feet would change the shape of continents on a map. It would permanently flood the southern third of Florida. It would submerge huge sections of Bangladesh where over 160 million people live. It would turn parts of lower Manhattan, entire neighborhoods in London, and coastal areas all across the Pacific Islands into land you can't live on anymore. We're talking about hundreds of millions of people who would have to move. Those are not numbers that show up in a headline and then stop mattering. Those are numbers that reshape human civilization over the coming centuries. But nobody knows exactly how fast this will happen. That's the honest truth, and I'm not going to pretend otherwise. Some scientists think the worst effects play out over several decades. Others think the process could stretch across a couple of centuries, and there's genuine active debate among researchers about the timeline. This is not fully settled science at its edges, and not all the recent findings are terrible. A 2023 study actually modeled what would happen if the ice shelf disappeared completely and found that it might not speed up ice loss as dramatically as the scariest prediction suggested, at least not over the next 50 years. Some research on a scenario where tall ice cliffs collapse under their own weight, which was one of the most alarming possibilities a few years ago, also came back more reassuring than expected. That particular worst case now looks less likely. So the science has real nuance. This is not a situation where every new study makes things worse. Some findings are scarier than expected. Others are less scary. That's how real science works. It doesn't just march in one direction. It fills in a picture, and the picture turns out to be more complicated than the first rough sketch. But here's what is not in debate anymore among the people who actually study this glacier up close. Thwaites is going, the ice shelf is going, the glacier will speed up once it does. The seas will rise more because of it. The international team that spent 7 years studying this glacier summed it up clearly. The glacier's retreat has accelerated considerably over the past 40 years. A full collapse is unlikely in the next few decades. But it is set to retreat further and faster through the 21st and 22nd centuries, and a general collapse of the wider West Antarctic ice sheet over that time frame cannot be ruled out. That is the official conclusion of the most comprehensive study ever done on this glacier. Not doomsday tomorrow, but a clear, accelerating decline that will shape coastlines for generations. The only real question left is how fast it plays out. I think that's the honest, grown-up way to look at this. Not as a reason to panic, not as a reason to shrug and change the channel, but as a reason to pay attention, to care, to understand that the decisions being made right now by governments, by cities, by all of us about how we build near coastlines, about how we plan for rising water, about how seriously we take the warnings that scientists are putting in front of us, those decisions will echo for generations. The people most affected by this won't be you and me. They'll be our kids, our grandkids, the people who inherit the coastlines and the cities and the islands that we're making choices about today. And they'll look back at this time and either thank us for listening to the science or wonder why we didn't. One last thing worth saying, the scientists who study Thwaites have never loved the name Doomsday Glacier. Journalists came up with it, and most researchers think it's too dramatic. Because when people hear doomsday, they picture a disaster movie, a tidal wave, a single explosive moment where the world ends. That's not how this works. This is a slow, grinding generational process, one where every year a little more ice is lost, a little more water enters the ocean, and a little more coastline gets a little more vulnerable. That doesn't mean it's not serious. It might actually make it harder to deal with because a slow crisis never gets the same urgent response as a fast one, even when the total damage from the slow one ends up being far, far worse. The giant isn't falling today, but it's losing its grip. The brake is failing, and the scientists who have given their careers to understanding this want the rest of the world to be watching when it finally lets go. That's the real story of the Doomsday Glacier. No panic, no hype. Just the science told straight. I'm going to keep covering this as it develops because that ice shelf could break apart any day now, and when that headline drops, you're going to want someone who gives you the real version. Hit subscribe and turn on notifications so you don't miss it. A thumbs up helps push this to more people who deserve facts over fear. Now I want to hear from you. Drop a comment and tell me. Did you know about the Thwaites Glacier before this video, or is this the first time you're hearing about it? I read every single comment, and I'll see you in the next one.